me what it is and why we would use it.
What is it? Because I wasn't here to learn about it.
Okay. Somebody want to help Emma?
Like when numbers like either really small or really big, you try to represent it by using like 10 to the power 9.
A way to represent extremely large or small numbers. That's what it is. Today, we're going to be talking about not only how to, just refresher about how to represent it in scientific notation, but actually how to work with those numbers. How can we add them? How can we subtract them, multiply them, and divide them? Because those are our four major operations dealing with math, right? Add, subtract, multiply, and divide. So, in this first one, it says, write this number in scientific notation. And we learned that the number in front of the decimal needs to be between what two numbers? Between 1 and 9. So I know that the decimal needs to be here. So it's going to be 2.84 times 10 to the what power? Fifth power. Because I'm going to have to move that decimal 5 places to get it here. Okay? In example 2, where does the decimal want to be? Between the 2 and the 6. So I want to write 2.68 times 10. And this time, 1, 2, 3, 4, 5. I moved 6 places, but I moved a different direction. So I want a -6 as my exponent. Okay?
How can you have a negative number as an exponent? I thought you said that we could not.
Only time we do it is when we have scientific notation. And the reason that it works is because this really should be this, which means I'm taking 2.68 and dividing it by 10 to the 6th power. And when I do that, it's going to give me back this decimal. So I'm not changing the value of the number. I'm changing what the number looks like. And it's easier to work with this than it is to keep track of these zeros. That 6 is basically keeping track. That -6 is keeping track of where that decimal point is, and we don't have to write down all those zeros. By the way, this number relatively isn't that hard to work with. But what if it had 23 zeros or 50 zeros, where the numbers are getting extremely large and extremely small? Then it becomes harder and harder and harder to keep track of where that place is. So we use scientific notation to take care of that. But you remember doing this the last couple days, excluding you, which weren't here, right? We're good? So, take a look at number 1 and number 4. You take a few seconds, convert these from standard form to scientific notation on number 1 and 4 there on your sheet. Then I'm going to write them down. We're going to look to see how you did. Okay? Okay. The decimal wants to be here, 7.5 times 10 to the 3, 6, 7th power. So you should have 7.5 times 10 to the 7th. 8.52 times 10 to the 1, 2, 3, 3, negative third power. Everybody okay? Question? How many places did I move it? 1, 2, 3. Right?
So if it's like in the if it's like number one and you have to it's a positive exponent, you count all the way to the end of the zeros on this side.
That's right, because the decimal is implied to be at the end. Okay? And that's what we're keeping track of. How many places did I shift the decimal left, or how many places did I shift it right? Okay? When we're converting scientific notation to standard form, we're undoing that process. The number that's on the exponent tells me how many places the decimal is going to move and what direction it's going to move. Okay? 2 places, it's positive, so it's going to go to the right. This becomes 254. This one says negative 2, so it's 2 places to the left. When I move it 1 place, I'd be here. So when I move it to 2nd place, I've got to remember to put in that lead 0. Questions on 7 or 10? Okay. Question?
And like, I know we didn't go over it, but on the first section for number 2.
Okay. Today, this is new for today.
On the last page,
Yep.
on like 10, can you put a 0 in front of the decimal point?
You can. You're saying, can I put a 0 here?
Yeah.
Yes.
And standard form is
The way we normally read numbers. It doesn't have the exponents and the powers of 10.
and scientific notation is the equation.
Scientific notation is when it is represented with a power of 10. That has a power of 10, and the number in front of the decimal is between 1 and 9. It's in scientific notation.
So
Okay?
it's the way you look at it is like an equation.
Kind of, yeah.
Yeah.
Are these two numbers different in value?
Yes.
Are they different in value?
No. The answer isn't. No.
Are they different in value?
No.
They are what?
Equal.
Equal. They look different. It's no different than when you leave class, you go home. When you come back, you probably are wearing different clothes. Most of you. Right? Are you a different person, or is it still an equal person? Equal. It just changed appearance. These are equal numbers. It just changes how it's dressed.
Because I was confused on like the way it's written, like scientific notation and standard form. I was like confused on how like which one goes with which. The standard form is like.
This is what? Scientific notation. This is standard. This is the way we typically write numbers. Now, both of these numbers, I would say, typically we would write them in scientific notation. Why? Because they're not that big or they're not that small. We just typically wouldn't write them that way. We'd work with .067. There's really no reason to change it. We'd work with 254. And in the real world, this just isn't a very big number, is it? I mean, it may even seem like a lot of money, but it's really not in the big scheme of things. $254 wouldn't even get you a lot of product, would it, in today's society? Might buy you a lot of bubble gum or something. It's really not a lot of money.
It's weird how a few decades ago about how like 10 cents could
Oh, yeah.
buy you a lot.
Are we good? So, now let's talk about how we are going to add and subtract. Addition and subtraction is the harder of the two to me. Multiplication, division is a little easier. It says make sure exponents are the same. And it says use, and they created an acronym. It says LARS, use LARS. And it stands for left you're going to add, right you're going to subtract. Okay? So if you have to add to the exponent, I've got to move the decimal to the left. If I have to subtract from the exponent, I have to move the decimal to the right. That's what it stands for. The reason that we have to move the decimal, that we have to have the powers the same, is it is in fact what lines up our decimal point. It doesn't matter which one we change. I really recommend you change it to the larger of the two. I would keep this number. It has the larger exponent. 9.5 times 10 to the 7th. I would change this one so it said times 10 to the 7th. Because my exponents have to be what? The same. It is, in fact, what's lining up my decimal. Okay? Now, since I added an exponent, which way do I have to move my decimal? To the left. I added one decimal place, so I've got to move the decimal one place to the left. Is everybody with me on the first step? I had to make the exponents the same so that my decimal point would be lined up. If you were adding in standard notation, they teach you to line up the decimal point and then add. Now you can keep this. It's going to be times 10 to the 7th. And all you have to do is add the piece that's out in front. What is 9.5 plus 0.11? 9.61. So, when I add them together, if I've got the exponents the same, all I have to do is add the numeric part that's out in front of the exponent. Because the exponent is merely keeping track of where that decimal point is. Everybody understand what I did? I look at my 2 powers of 10. My 2 powers of 10 have to have the same exponent. 10 to the 7th, 10 to the 6th aren't the same. If I looked at these in standard notation, they'd be shifted. The 9 wouldn't line up with the 1. Okay? The decimal is being lined up by this power of 10. So to line up the decimal, the 2 powers of 10 have to be the same. It really doesn't matter which one you change. I recommend you keep the larger exponent. There's usually less steps involved if you do that. I usually don't have to change this number when I get done. Okay? Now, because I wanted to change this to 10 to the 7th, I had to add 1 to my exponent. If I add 1 to my exponent, I have to take that decimal place away from the number that was out in front of it, so it has the same value. In other words, if I'm adding, I'm going to move the decimal left. okay? Because it takes that place value back away from it. So I'm still dealing with the same value, I've just changed the way it appears. Just like when you add fractions, the denominator stays the same, right? 1/3 plus 1/3 is what? 2/3. The denominator stays the same. This is very similar. The 10 to the 7th is going to stay the same. And all I have to do is add the numeric part that's out in front. So I add the 9.5 and the 0.11 together. And that gives me the 9.61 times 10 to the 7th. We good? Subtraction is the same thing. Makes no difference whether you're adding or subtracting. The rules still apply. So, here's my question. Which one has the larger exponent? -6 or -7? -6 is larger, right? You'd rather owe somebody $6 than you would owe them 7, right? So I'm going to keep this one because it's larger. So you're going to see I'm just going to bring this down, 4.22 times 10 to the -6. Okay? I want to make this 10 to the -6. What did I do to this -7 to make it a -6? I added 1. Okay? I added 1. -7 plus 1 gives me a -6. If I add 1, what's going to happen to the 6.8 that was out in front of it?
0.68.
It's going to become 0.68 because I've got to move it one place to the left. What am I going to do with the 10 to the -6 power? Say it. Nothing. I'm going to bring it down. It's not going to change. The only thing that I'm actually going to subtract then is the numeric pieces that are out in front. I'm going to take 4.22 and I'm going to subtract 0.68 from it. Well, in order to subtract the 8 from the 2, I'm going to have to borrow. 12 minus 8 is 4. Going to have to borrow from the 4. 11 minus 6 is 5. And 3 minus 0 is 0. (3.54 times 10 to the -6). Okay. So, with an addition and subtraction problem with scientific notation, it's important that the exponents have to be common. They've got to be the same because it's what's lining our decimal point up. Okay? Questions on 2 or 10 that I've worked out here? So, when you're multiplying and dividing numbers, use the product rule or the quotient rule. So out there on the side where it says multiplying and dividing, please write down the product rule in that little bar space that's there beside it. The product rule says this: x to the a times x to the b equals x to the a plus b. Okay? The product rule says x to the a times x to the b. I'm multiplying, have right bases. I add exponents. This is what we talked about On Thursday, Friday, and Monday, we spent 3 days talking about exponent rules. Okay? The quotient rule says if I have x to the a divided by x to the b, instead of adding exponents, I subtract them. X to the a minus b. Okay? So, we're going to use the product rule or the quotient rule to change the exponent, and we're going to use Lars to adjust the decimal when we get done. In other words, if I have to move the decimal left, I'm going to add. If I have to move the decimal right, I'm going to subtract. Okay? Now, with that being said, since this is all multiplication, right? All the things are being multiplied together. Does the order matter? No. So what I want you to think about is we're going to reorganize this. See what I did? I put my powers of 10 together and my numbers together. This is the easy part. What's my power of 10 going to be? 10 to the 21st power. Because I'm going to use the product rule and add my exponents together. This is a calculator thing, or you can do long multiplication. For the sake of time, I'd rather you use what? Calculator. So somebody go ahead and multiply 7.5 times 2.5. I'm sorry?
18.75.
Here's my question for you. Is that in scientific notation yet? No. Can you tell me why? The decimal's not in the right spot. The number in front of the decimal isn't between 1 and 9. In order to make the decimal between 1 and 9, I have to have 1.875. In other words, I move to the left. What do I have to do with the exponents? I have to add 1. I took 1 away, so I have to add 1 back in, times 10 to the 22nd, because I've got to add that 1 decimal place that I moved. Okay? So to me, multiplying and dividing is easier because I don't have to make my powers of 10 the same to start with, and all I'm realistically doing then is multiplying two numbers together and adding exponents. Likewise, when you look at number 10, it's the quotient rule. So again, I'm going to rewrite this. I'm going to write 2.1 divided by 2.8 and 10 to the 7th divided by 10 to the 3rd. Okay? Because this was 18.75. So to put it in scientific notation, the number in front of the decimal has to be between 1 and 9. I had to move 1 place to the left. If I use Lars, I move to the left, I have to do what with the exponent? Add. Okay? If I take a decimal place away, because I'm moving to the left, I've got to add the decimal point back in on the power of 10. Remember that power of 10 is keeping track of where the what is, where the decimal is. So if I change the decimal, I've got to change the power of 10. Okay? So, again, the easiest part to take care of is the power of 10, we're going to apply the quotient rule. What do I do with exponents? I subtract. So this is going to be times 10 to the 4th power. 7 minus 3. This, again, I can do on a calculator 2.1 divided by 2.8.
0.75.
Is this in scientific notation?
No.
No. Why?
Because
The number in front of the decimal is 0, which is not between 1 and 9. So what I'd like it to be is 7.5. This time I move to the right. If I move to the right, I have to do what? Subtract 1. So this will be 7.5 times 10 to the third power.
So, never mind. I just answered my own question.
Again, if I'm adding a decimal point here, I'm going in a positive direction. I got to make sure that I take that decimal point away from my power of 10, which is holding its place.
Yeah, what I was thinking about is how they already had 10 to the third power and how it ended up being 10 to the third.
Yeah, and that doesn't always happen that way. Okay? Everybody good? Okay. We are going to take the mastery test. When you're finished with it, you should do what? Finish the worksheet. Yes.